Hey there, it's All Saints Day, November 1st, and we're going to do some math. Actually, Unit 3 of Apex is called Quadratics, involving the quadratic formula, involving solving functions with roots, parabolas, that kind of thing. First of all, we want to learn and go back and review some factoring. There's some basics of factoring. So let's go to the board and check out some factoring problems. Okay, there are different types of problems. This is a binomial, two terms, and this is called difference of squares because the square root of this, square root of 1, if I take the square root of 1 as 1, the square root of 49 is equal to 7. So I have the two things that I can use to factor this. I have 1x here times 1x there is equal to 1x squared. Then if I FOIL it, I'm going to get, I'm going to have a 7 here and a 7 there. Now, if that's a minus, then this can be plus 7 and minus 7. This is called difference of perfect squares, and this is the form it takes. It'd be plus and minus the square root of that number right there. So our answer is x minus 7, x plus 7. Why does it work? Well, check it out. When you FOIL it back, you get x squared, like back to this way, minus 7x plus 7x, and the middle term cancels, minus 49. You see how that works? That's why we ended up with a binomial, because the middle terms cancel because these are opposite, plus and minus. Trinomial squares are a little bit different, but you can see a pattern happening here. We got our perfect square over here. The square root of 25 is 5. I'll just write that out so you guys remember. And we can use that. This is another square root of 1 equals 1, so we can use that. Now it happens to be that in this case, these add up to make the middle term in the following fashion. This is going to be x plus 5. We take half of the middle term and square it, and if we get that, it works, right? We get 1/2 of 10, the middle term, is equal to 5, and then we square it, we equal 25. That's a trinomial square. The middle term in half squared is the outer term, and then our answer is going to be basically just that, x plus 5 squared. Let's check it. For a check, we have to FOIL it back out. We write x plus 5 twice because it says x plus 5 squared. Sorry, we're not with that there. We've written it out twice to include that exponent. When we FOIL it back, we get x squared plus 5x. Now, what we're getting here is we're not getting that middle term canceled, right? Plus 25, and we're ending up with x squared plus 10x plus 25, which is what we want. So that's our check. This is our answer. And we're done. Now, notice the difference between this question and that question. These guys are opposite, middle term cancels. That's why we end up with a binomial. These are not opposite. The middle term stays. We have a trinomial. But it's a perfect square trinomial because the middle term can be halved and squared in order to make 25. This has something to do with completing a square, which we'll work on later in the chapter. Let's go over to 3 and 4. Now, this doesn't work in terms of anything. This is not a perfect square. There's no common factor that we can take out of there. But we can notice that the factors of 6 and 1 and 3 and 2, a pair of those are going to work in a very particular way. We put our x and x down because x times x is x squared. And now we're going to use 3 and 2 because we know that those two, if we add the two of them together, we're going to get negative 5x, because they have to be negative though, right? Negative 3 plus negative 2 adds to be negative 5. And we can check that. We know that this is going to be true because we know how to work this, but let's check it anyway. We go ahead and FOIL it. X times x is x squared. We got minus 2x there, minus 3x here, and then minus 2 times minus 3 is plus 6. We got that on the end. This is all going to add up. X squared minus 5x plus 6. So there's our check. We have it. This was not a trinomial square nor a difference of squares, but it was factorable because we can get the pairs of factors of the last term and make them and work them so that they combine to be the middle term, whatever way we can. This is looking suspiciously like difference of squares. You guessed it. The minus sign here, perfect square, perfect square. What is the square root of 25? It's equal to 5. What's the square root of 100? It's equal to 10. And we use that. Except for this time, the difference between number 1 and this is that we have a leading term, 5x minus 10. And remember, difference of squares, we have a binomial because this is 5x plus 10. That's going to make the middle terms cancel. We make a check. 5x squared times 5x squared is 5x times 5x is 25x squared. That's going to be 50x. 5 times 10 and it looks like, uh-oh, we got a way too big number, but no, the minus 10, that's minus 50x. And then we have negative 100. We got what we want because those cancel. 25x squared minus 100, boom, that's what we have. So it's a difference of squares. It's a little more complicated than this because the leading term here was a 1, and this is a 25. But 1, if you think about it, is a perfect square, so is 25. It's really the same process. Let's finish with these last two as our examples. Uh-oh. Is this difference of squares, guys? It's a trick question because it's not difference of squares. Therefore, guess what? We can't factor it. Time after time they put this on tests. Time after time people try to factor it. It is not factorable. It's not difference of squares, so we cannot factor it at all. So on this one, a little tricky looking, we have a leading perfect square. An outer perfect square, we square rooted of 4 is equal to 2. Square root of 1 equals 1. We can do what we've been doing, and we put our 2x here, our 2x here, because 2x times 2x is 4x squared. We know these are 1. Is it going to work? Are we going to get a middle term that's minus 4x? Well, we're certainly not going to get it if we put a plus and a plus here, but if we put a minus and a minus there, we might just do it. Let's check it out. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. That's minus 2x. Looking good. That's plus 1. That's what we want. And look what happens, guys. 4x squared minus 4x plus 1. Our check is complete. We got it. It's done. And this is also a trinomial square, by the way, because we could write our answer right here as 2x minus 1 squared. That's our answer right there. Trinomial square, not factorable because of the plus sign. Difference of squares, regular, it's not nameable in that sense. It's a regular trinomial. This over here is a trinomial square, and this one over here is difference of squares. So that's a quick review of factoring. You'll see why it's needed in a moment because we're going to start solving quadratics.